Friends, my name is Satyajit Sahu and today we will have a very interesting session. Yes. So, we all have completed our GATE 2023 journey, right? And many of the students are now started their preparation for GATE 2024 and also Engineering Services 2024. In both the examinations, now we know that mathematics is a very important topic, right? It's a portion, not topic. Yes. So therefore, now we'll be having regular mathematics and aptitude guidance also for the students. Okay. So today we will have an interesting topic, that is mastering probability distributions, right? So I'm going to teach you the very basics of probability distributions. So welcome Samriddhi, welcome Lakshmi, yes, and welcome to all the students who are watching this lecture recorded. Yes. Now, as I told before, and many of you know, if you don't know, I will repeat that mathematics is going to be a very important topic for your GATE examination. Because again, I will take not a topic, it's a portion, right? It's a subject, right? So therefore, it's very important that we have a very structured preparation for mathematics. And that can be only done if you are following right guidance. Otherwise, the syllabus of mathematics is so vast that you might get entangled into the various aspects. Yes, it's very important to understand that what exactly we have to study in the big syllabus of mathematics, right? So we will be guiding you in the months ahead. Yes, not today, it will be continuous, a continued guidance program, we can say. Yes, but today we are going to see what? The probability distributions, discrete and continuous. Okay, so let us start the session without any further delay. Yes, you can go through my introduction. This is me Satyajit Sahu. Okay, I have done my BTech and MTech both from IIT Kharagpur. Yes, and currently I am associate director in BYJU'S GATE division. Yes, so let us start the lecture without any further discussion. Okay, just one last announcement that on Thursday, as we have started today mathematics, yes, we'll be having aptitude sessions also. On Thursday, I will be taking a lecture on your exponents and logarithmics. Okay, it's a very interesting topic and lot of questions are asked not only in GATE but in any competitive exam where aptitude is an important portion. So if you are preparing with me for your general aptitude, okay, so not only I will be covering portions which are relevant for GATE, but I can say it will be more a overall package. Therefore, I have given this name what? Aptitude Boot Camp. So I am giving this name what? Aptitude Boot Camp, because I am not only fixing to GATE syllabus, because students who are appearing for GATE and studying the aptitude, they will be always also appearing for what? ESE. Will also appearing for what? SSC, JE and many other examinations, and in all these examinations your aptitude is an important part, and therefore on Thursday we are going to start this, so stay tuned. Let us start today's lecture without any further delay. Let us start it. Okay? Without any further delay, let us start it. Okay, so let us have basic definition of mathematics in respect to what? With respect to your probability distributions. Okay, so first thing is that we will understand what is an experiment. What is an experiment? Okay, we'll understand a few terms which you might have studied before, but I'm assuming that suppose you have not studied. So experiment. What is an experiment? Any activity you are doing is an experiment, right? You go from home to your school or college, that is experiment. You are eating food, that is also an experiment. So basically any activity can be called as an experiment actually. Any activity can be called as an experiment. Okay. Let us have a very simple example which always we take from childhood, right? That is, suppose you are tossing a coin. You are tossing a coin. Okay, tossing a coin, or you are rolling a dice, right? You are rolling a dice. Yes. These are what? Example of experiments. Now, next we will see a term known as what? Sample space. Next we will see a term known as what? Sample space. Now, what is a sample space? What is sample space? The output of this experiment and if you enlist them, that is known as what? A sample space. Meaning what? Suppose I am tossing a coin. So in tossing a coin, what will sample space? Either it will be head or it will be tail. So this is what? The sample space of what? You're tossing a coin. Now, what is the sample space for rolling a dice? That will be either 1, 2, 3, 4, 5 or 6. Right? Now let us engage you. I'll engage you people, okay? I'll engage you people. Suppose I am telling about tossing 2 coins. Tossing 2 coins. Okay? Tossing 2 coins. Now, understand this, that in this tossing of a single coin, there are 2 sample points. There are 2 sample points, right? Either it is head or it is tail. So now, when I am talking about tossing 2 coins, there will be a sample space. In that sample space, can anyone tell me how many sample points will be there? Tell me, how many sample points will be there? Now, engagement of the students, okay? So it will not be, one-way discussion. It will be, two-way discussion. So tell me, what will be the number of sample points in this sample space? Number of sample points in this sample space. Number of sample points in this sample space. Yes, the answer is 4. Very good. The answer will be 4. So the answer will be what? Either it will be head or head. Both head, right? 2 coins are there, right? So either it will be head and head. Or it can be head and tail. So head in the first coin and tail in the second coin. Or it can be tail head. Or it can be both tail. Yes, both tail. So there are 4 number of sample points. There are what? 4 number of sample points. Clear? Now, this thing you might have studied in your childhood, in your, we can say, college days, 11th, 12th, or, class 10th. Yes. But let me introduce something which you might not have heard before. That is your random variable. That is what? A random variable. Now, definition is not that important. It is important to understand the concept. So to understand the concept behind it. Okay? Rather than memorizing definitions, that is not going to be helping us. Let us understand the concept behind it. Random variable. Now, understand, first of all, random variable, suppose I am giving the name X. A random variable is not the outcome of the experiment. Yes. Now what is the outcome of the experiment? The outcome of experiment is sample space, right? And in sample space there are sample points. Like see, this is sample point, sample point, sample point, sample point. So in a sample space there are sample points, and this is the outcome of the experiment. But random variable is not the outcome. What is the random variable? Random variable is a real number. Okay, it's a real number. Okay, real number assigned to each sample point through a particular definition. You'll understand that. Pardon me. Through a particular definition. So I'll request all of you that you don't focus so much on remembering the definition. Okay. You should understand the definition. Okay. So I am telling that it is a real number which is assigned or associated with each sample point. Okay. Let us understand this. Suppose I am telling that this tossing of 2 coins. So tossing of 2 coins. So when there is tossing of 2 coins, what is happening? You see, when we are tossing 2 coins, this was sample space was what? Either it was head head, or head tail, or tail head, or tail tail, right? This was sample points. Now suppose I am defining a random variable. Suppose I am defining a random variable See, X is just an indicative. It can be Y, Z, anything. Suppose I am telling random variable Z, and what definition I am giving? I have to define it, right? Suppose I am giving a definition that number of heads. I am giving definition what? Number of heads. Then tell me, this Z value for the first sample point is how much? This Z value for the first sample point will be how much? Tell me. This Z value for the first sample point will be how much? Will be how much? Tell me. What will be the value? Tell me. The value of Z for the first sample point. This is the first sample point, HH. What is the value of this? Very easy. What is the answer? 2, na? Yeah, it is 2. Because there are 2 heads. For second sample point, 1. For third sample point, 1. Then again 2. Yes. Now suppose I give another definition. Suppose I am having Y. And I am telling Y as what you know. Suppose I am telling Y is number of tails. I am telling Y is number of tails. Number of tails. Then what happens? Y number of tails. What happens? You see? HH. Here it becomes 0, na? Sorry, here it should be 0. I wrongly written here 2. It is 0 here. Okay? So it is 0 here. And then here 1. Here 1. And then here 2. That means you can see that this value of random variable, good evening, this value of random variable, yes, the value of random variable is depending on the definition. Yes, you see, this is not random variable. This is what? Sample space. So the outcome is not the random variable, okay? The outcome is not random variable. This is the outcome, na? This is the outcome of what? This particular experiment. Yes. So when we are doing an experiment, the outcome of that is what? The sorry, the sample points. The sample points. Right? The outcome is the sample points. Yes. But the random variable is something different. Okay. Something different. Okay. And that value depends on what? The definition we give. Okay. Definition we give. Okay. Now, suppose I am defining another experiment. Suppose tossing 3 coins. Suppose I am giving another experiment. 3 coins. If I toss 3 coins, there will be a lot of outcomes. No? They give a lot of outcomes. Suppose I am telling head, head, head. Yes. Then it can be head, head, tail. Yes. It can be head, tail, head. It can be tail, head, head. Right. Then it can be head, tail, tail. Yes. Then tail, head, tail. Yes. Or tail, tail, head. Or then tail, tail, tail. These are the outcomes, right? The outcomes, right? This can be the outcomes. Yes. So this is what? Sample space. So how many sample points are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 sample points are there. Suppose I define a random variable. Suppose I define a random variable. This is what? A random variable. Now what will be the value of random variable? If I ask you what will be the value of random variable, then you will tell me, sir, the value of random variable depends on the definition I give. Yes or no? What you will tell? Sir, this value of random variable x depends on what definition I give. So I am giving the definition of what? That number of heads. It can be anything. It can be like this also. It can be, sum of number of heads and some number of tails. Depends on what definition I give. Suppose I am telling number of heads. Then what happens? What happens to this x then? What happens to this x then? You see, here it is 3. Yes. Here it is how much? Here it is 2. Here it is 2. Here it is 2. Here it is 1. Here it is 1. Here it is 1. Here it is 0. So tell me, this random variable x is taking which values? It is taking 0, 1, yes, then 2 and then 3. Yes, this is the number of heads, right? This is the number of heads. Everybody understood that how this random variable is defined? Yes, random variable is defined, right? Now you see, if I draw a table like this, x is taking which values? It is taking 0, 1, 2, 3. Yes. Now see very carefully that these random variables are not the outcome. The outcome is this only, na? You see, the outcome is which one? The outcome is this one. Now the random variable is a number which depends on the outcome and also the definition which you give. Very good. Now suppose I want to find out the probability that the random variable is 0. So P of x is what? Probability. P of x is what? Probability. Yes, this is what? Probability of x getting this value. Now see how many sample points are there. The total 8 sample points. Now you see, total 8 sample points are there. And 0 we are getting how many times? Once. Na? So what will be the probability? The probability will be simply 1 by 8. Because there are 8 sample points, and in all these 8 sample points I am getting this random variable 0 only in one case. Now tell me, what is the probability of this random variable 1? Tell me. What is the probability of this random variable 1? Tell me. What is the probability of this random variable 1? Tell me. What is the probability of this random variable 1? Tell me. Others also contribute. It is 3 by 8. It is 3 by 8. Because you see I am getting 1 3 times. Yes. And similarly for 2 also I will get 3 by 8, and for 3 I will get 1 by 8. So this is the way I find out what? The probability. And this is also known as probability mass function. It is also known as what? Probability mass function. Right? For different random variables I am getting a particular probability. And how I am getting? We understood. Yes, and these probabilities are known as what? Probability mass function. So this is a random variable x. Yes, this is what? A random variable x. Yes, and the value of random variable depends on the definition which we give, and then we have this probability mass function. Yes, probability mass function. Right? Understood. Now let us understand some features of this probability mass function P of x. Let us understand some of the features. For that we need another slide, so we'll add a slide here. Okay. Okay, we added slide. Nice. Okay. Let us go ahead. You see here properties of this probability mass function. Okay. Now first of all, this random variable x, this random variable which you got x, tell me, this random variable x, is it discrete or it is continuous? Tell me. It is discrete or it is continuous? Tell me. It is discrete or continuous? It is discrete or it is continuous? Tell me, it is discrete or it is continuous? This random variable x which we defined here. Now discrete means what? Distinct points. It is not continuous, it is discrete, right? Why? You see, it can take 0, it can take 1, it can take 2, it can take 3. Can it take 1.1? Number of heads, can it be 1.1? No. Can the number of heads can be 1.13 or 1.53? No. Yes. So number of heads, the random variable definition itself gives a discrete output. Yes, discrete output. So therefore this is what? Discrete random variable. Yes, it is what? Discrete random variable. Yes. And then we have this PMF, or I can say what? Probability mass function, which we got. Yes. For different random variables, we have different value of this. Yes. A very important property of this probability mass function is what? What is the important property? Very important property is what? That the summation of P of x is equal to 1. Yes. Obviously, summation of all probabilities would be equal to 1, right? Summation of all probabilities would be equal to 1. Yes. And you can see here, if you add 1 by 8 plus 3 by 8 plus 3 by 8 plus 1 by 8, you are getting how much? 8 by 8, right? 3 plus 3 is 6, 6 plus 1 is 8. So 8 by 8, that is what? 1. So this is the very important property, okay? We can start it because it will be used in solving lot of numericals. We use it to solve lot of numericals. So very important property that the summation of the probability mass function for all random variables x is what? 1. Is what? 1. Yes. Now here the random variable was discrete, so we got this. If it was continuous, it can be continuous. See, number, because that depends on experiment, right? See, our experiment was tossing the coins, and the random variable was number of heads. So number of heads will always be discrete, right? Yes, obviously. But suppose our experiment was, discharging water into a particular tank, and then after certain minute, calculate the volume. The volume will be not discrete, it will be continuous, right? It will be continuous value, right? Yes. So in that case, what happens? We will have a continuous random variable, right? So it depends on the experiment. Yes, depends on the experiment. So we get what? Continuous random variable. And when it is continuous random variable, we will not get distinct, right? We will not get distinct probability mass functions. Yes, we will get a continuous mass function. And that continuous mass function is known as what? F of x, that is what? Probability density function. Nothing but what? Probability density function, or PDF. Also known as what? PDF. In short, it is known as what? PDF. Understood, everyone? Everyone? So that means what? So if I summarize here, I'll erase this. Okay, not required. So we got that random variable can be of two types, right? We got what? A random variable can be of two types. What types? First, it can be discrete. Yes, like we saw the example of tossing of two coins. And then it can be what? It can be continuous. It can be continuous. So in continuous, we'll get continuous data. Yes, means what? Suppose volume of water. There can be 1.1 liter, there can be 1.25 liter, there can be 1.75 liter, yes, anything, right? It's a continuous data. But suppose I define the random variable as what? Number of heads, it will always be distinct, or it means discrete, we can say. It will always be discrete. It can never be continuous. Number of heads will be always discrete. You cannot have 1.3 heads. Yes or no? Yes. So, two random variables we saw. And the probability here, the probability mass function here which we are getting, this is known as what? PMF. Probability mass function. 1 second just. Okay. So it is PMF here, and here it is known as what? F of x, that is what? Probability density function. It is what? Probability density function. Yes. Very nice. Same thing, just called different way, because here we have discrete probability mass function, and there it is called probability density function. Now the property, very important, the property. Here what we got, the summation of probability mass function is equal to 1. Because you see here we were getting something like this. If you plot it na, you will get something like this. This probability mass function, if you plot na, you will get something like this. You see distinct points. You will get what? Distinct points. You're just adding these values, right? That's a probability mass function. But if you are seeing this PDF na, f of x, you will not get a distinct, you will get a curve like this. Yes, and in curve what we do, if we want to find out the summation, we have to take the area, right? Take the area, right? Area between this. And how we take the area? We take the area as the integration, yes, definite integral. So here what happens, the definite integral of f of x dx from minus infinity to plus infinity, that will be equal to what? 1. Because total probability will always be what? 1. Na? Total probability will always be 1. So it will be what? I can say it will be 1. Everybody understood this point or not? We'll go ahead. Just everybody just write in once in comment section that you have understood this or not. Then we'll go ahead. Okay. Okay. Why we are taking integration? Because here it is continuous. So when you want to add continuous, it will take what? Integration, the area, right? Whereas in discrete, they are discrete points. So I am just taking summation, adding them up. Yes, just adding them up. Understood? Easy. Okay. Now suppose this f of x is defined in an interval x1, x2. It is possible. Defined in the interval x1, x2. Yes. Then this integration will change to what? It is not defined from minus infinity to plus infinity. Suppose between the limit it is defined. So it will be what? It will be from x1 to x2 f of x dx. That is equal to 1. That has to be written in the question that it is defined between what to what. So understanding these principles, let us start solving questions now. Let us start solving questions now. So I'll just revise finally and then we'll solve questions now. So we have a random variable. Yes, the random variable is assigned to what? The sample point, and the value of random variable depends on the definition you give to it. Like in the tossing of 2 coins, we give definition of what? 2 heads. Easy. Yes. And then we saw that it can be discrete and continuous. Yes. And the probabilities, probability mass function and probability density function we saw. Let us solve questions now. Okay. So this is the first question. Yes. This is the first question. You can see a very typical type of question. So you can see that here the random variable x is given. Okay. The random variable x is given, and then the probability mass function is given. The probability mass function is given. So that means what? It's a discrete distribution. It's what? It's a discrete probability distribution. Right? Now it is asked to find out the value of k. It is asked to find out the value of k. So in such question, what you're going to do? You're going to use this property, what? Summation of your all the probability mass functions is what? 1. This I told this is a very important property, right? I told this is a very important property. So using this property, can you give me the value of k then? Chalo, solve and give me the value of k. By using this property, give me the value of k. Very straightforward questions which are asked in the examination. You can easily solve them if you understand the very basics which I explained. Chalo, batao, answer batao. One by 10. Okay, others? 0.1. Okay. Okay, let us see. You see, means what? Summation of all the probability mass function means what? Just adding this up, right? If you add this, you're getting how much? 10k. And 10k is equal to 1. So k is equal to what? 0.1. Very simple. Very simple. Starting with simple question and then we'll slowly move on to little difficult one. Starting with easy questions. Okay. Very simple question. We just use this property. Let us solve more questions. Let us solve this question. Okay. Let us solve this question. Now, it is written, again you see, I'll explain, don't worry. Here you see random variable x is given. Yes. Random variable x is given. And you can see that the probability mass function is also given. Probability mass function is also given. Very nice. Now see the first question. What is the first question? What is the probability of x is equal to 3? So the probability of x is equal to 3 is what? 2a na, you see. This is the probability mass function. This is the probability mass function. Yes. So the probability of x is equal to 3. The probability of x is equal to 3 is how much? Some problem happened. 1 second. No, not correct. So it is probability is 3. So answer is 2a. But to find out this 2a, we need the value of a. So everybody please solve and give me the value of a. Okay. Use the concept which I used in the previous question and solve. Chalo. Solve it. Solve it. What is the answer? Tell me. First to give me the value of a. Same thing I will do. Summation of your p of x is what? Summation of p of x is equal to 1. Yes. So I can say point, I'll add them up, right? Add this, add all of them. If you add all of them, how much you are getting? You are getting 0.6, 0.7. So 3a plus 0.7 is equal to 1. Or I can say a is equal to how much? A is equal to, I can say 0.3 by 3, that is how much? 0.1. I am getting again 0.1, right? Sorry. I am getting a is equal to 0.1. Yes. If a is equal to 0.1, then what is the probability of p x is equal to 3? The probability x is equal to 3 will be how much? It will come simply 2a, that is how much? 0.2. So by using this property, we got a is equal to 0.1. Yes. By using this property, we got a is equal to 0.1. And then directly we solved it very easily, right? And this answer we got what? It is 0.2. Now coming to probability x is greater than equal to 1. That means what? It can be either 1, right? Or it can be 3, or it can be 5. Now why not 2 and 4? Because they are not the random variables, right? You see the data set. In the data set, x cannot be 2 or 4, na? So if I see greater than equal to 1, so greater than equal to 1, either it can be 1, it can be 3, or it can be 5, right? So can you give me the answer to this? What is the answer to this then? Tell me. What is the answer to this? Tell me. Probability of 1 is how much? It is simply a. That means what? 0.1. Probability of 3 we just got 0.2. And probability of 5 is what? 0.2 given. So answer is how much? Answer is 0.5. 0.5. Now coming to this. Can you give me the answer to C answer? Let us see who answers this C correctly. Let us see who answers this C correctly. Please answer the C. Please answer the C. Answer C. See the signs properly, okay? .7, okay. You see, greater than equal to -1. So it can be -1, it can be 1, it can be 3, but it won't be 5. Why? Because it is written less than 5, right? So it can be either the probability you are finding what? Either probability of -1, yes, because -1 is included, less than equal to, then probability of 1, and then probability of 3. So probability of -1 is how much? Probability of -1 is 0.4. Probability of 1 is a, that is how much? 0.1. And then probability 3 is 0.2. So we're getting how much? 0.7. You can see that we're easily able to solve this question. It's a very easy question. They just look difficult. By understanding the very basic property of the sum of all the probability distribution function is what? Probability mass function is what? 1 in case of discrete data. Let us go ahead. Let us see something else. Okay. Let us go to your continuous one. Let us go to continuous. This is continuous. Yes. You can see this is continuous because what is given? This is a probability density function, right? You can see it is f of x. That means what? It is probability density function. That means what? It is a continuous function. It is what? It is continuous. So when it is continuous, and x is defined from minus infinity to plus infinity. The definition is given, okay? And they asked to find out k. So what property we'll use? We'll use the property that the integration of fx dx in its interval of definition means what? From minus infinity to plus infinity will be equal to 1. Yes, this is the property of what? Probability density function. Now using this, can you give me k? Yes, you can get k. How? Very easy. I'll just integrate this. Sorry. K by 1 plus x square dx is equal to 1. So when you integrate this, you can take this k outside, right? K outside. So now this 1 by 1 plus x square is a even function, right? So you see minus infinity to plus infinity. What I can do? I can make it 0 to infinity and then 2 times, right? That's the property of integration in case of your even functions. Yes. So if you see f of x dx minus a to a, if it is an even function, the same as what? 2 times of 0 to a fx dx. This property I used. Yes. Yes. Now see, this 1 plus x square integration is what? Tan inverse x, na? Yes. So what we got? 2k tan inverse x. Yes. The integration, this is like you have studied in your childhood, you might have forgotten. I am just making you remind. So to do k tan inverse x, the integration is what? Means integration of 1 plus x square is what? Integration is tan inverse x, right? We know that is the standard property. So this is equal to 1. But the limits are what? Infinity and 0. Now when you put the limits, it is 2k. Now what is tan inverse infinity? Tan inverse infinity is pi by 2, na? And tan inverse 0 is what? Tan inverse 0 is 0 only. And this is equal to 1. So 2 to get cancelled and get a value of k is equal to what? 1 by pi. Yes, I get a value of 1 by pi. Because this is actually equal to what? 2k into your tan inverse infinity, right, minus tan inverse 0. And tan inverse 0 is 0 and tan inverse infinity is pi by 2. You see, you have to study mathematics in this manner, right? If you not studying, now students what they do, why we are starting mathematics now. Many students are committing these mistakes. What they think that they will not study mathematics and before the exam there will be a marathon and they will study that from the marathon. And then they will get marks. Yes, from marathon you will get marks. Sometimes some students get full marks also. It is a luck. But most of the time what happens, if 13 marks is mathematics, they'll end up with 8 marks or 9 marks. And they'll lose 4-5 marks. See, even 4-5 marks are very important in the GATE exam. Right? And therefore you should not be doing this. And also in ESE prelims also, the same problem happens. So, we will not do this mistake this time. Okay? So very nice. Let us go to the next question. Okay, you can see this question. Okay, we'll see this question. Again, you see this is a probability density function given. That means what's a continuous. And it is given 0 to infinity. Now, when I see this particular probability P is x greater than 1. How to find out this probability? Very easy. Suppose this is the probability density function. Something is there. Suppose still infinite something is there. Okay. Okay, it starts from 0 and something is there. Now when I am telling, you see, this whole integration is how much? This whole integration is how much? The whole integration of fx, yes, from suppose 0 to infinity will be equal to 1. Because total probability is 1. Total probability is 1. But when I say that x is greater than 1, probability of x is greater than 1, that means what? I am considering this area, na? I am considering this area, na? So when I am finding this area, how to find out this area? This area is nothing but integration fx dx. This is 1 to infinity, right? Yes, 1 to infinity, right? Understood? So therefore I can say here this probability x is greater than 1. This can be rewritten as what? 1 to infinity integration f of x is how much here? E to the power minus x dx. Yes, and this will not be 1, total will not be 1, because 1 when I take from 0, that is definition, but I am taking here from 1. So what I will do? Very easy. This is what? The integration of e to the power minus x is what? Minus e to the power minus x. Then put the limits. So I can take this, I can take minus 1 by, I can take the minus sign outside, let me take the minus sign outside. It is 1 by e to the power infinity, yes, minus 1 by e to the power 0. Yes, so how much you are getting this value? Getting this value. See, e to the power infinity is what? E to the power is 0, na? Yes, and to the power 0 is 1. So I'll get plus 1, na? You're again getting plus 1, na, here. So everybody is getting 1 here answer. Everybody is getting answer here 1. So find out this, then solve this. So if you got this, solve this, and tell me what is the answer to this. Solve this then. Similar manner, solve this. Probability x is between 2 and 4. Solve this and tell me. That means there is, see, when I am getting x greater than 1 also this value, that means there is no function here. That means there was no function here, right? The function was starting from here actually. It's defined from there, but function is starting from there. Therefore I am getting all 1. So give me the answer to this B option then. Solve this. Same way, solve this. I am teaching random variables only. We are in random variables. First we saw discrete variables, discrete random variables, and here I am teaching continuous. That is only I am teaching. Chalo. Solve this question number B. Solve question number B. No, how I will get 1? No, I will not get 1 here. Solve this question number B. See what is given here? It is given probability that x lies between what and what? X lies between 2 and 4. Lies between 2 and 4. That means what? This will be integration of 2 to 4 fx dx. Yes, that means when I am finding the probability, I am finding from 2 to 4. That means what? I have to take this area. Yes, I have to consider this area. And how I will find this area? This area under curve, na? I will do definite integral. Understood everyone? Everyone understood this thing or not? See, in case of your discrete, what I was doing? I was just adding the values, because they were discrete values, we are just adding it. But in case of continuous, we cannot add the values, we have to integrate. Therefore, I am finding what? Integration, because that is your area under the curve. So tell me what is the answer to this? Answer to this. Solve this and give me the answer. Give me the answer to in decimals. Solve this and give me the answer in decimals. Solve this and give me the answer in decimals. Hey Baba. The integration of e to the power x minus x will be how much? This one. So 4, 2. So take the minus sign outside. 1 by e to the power 4 minus 1 by e to the power square. That is equal to 1 by e square minus 1 by e to the power 4. So how much you are getting? Almost you are getting 0.11 something you will get. So approximately 0.12 you will be getting. Others, they found out same answer. So when in case of it was, see, in case of your discrete, what you are doing? In case of discrete, when I am finding greater than equal to 1, I was just adding p of 1, p of 3, p of 5, because they are discrete values, right? I am just adding. But when it comes in case of your continuous, we cannot just add the values, you have to integrate. Understood everyone? Let us go to the next question. Okay, go to this question. You see, it is a. Tell me this is Tell me this is discrete or continuous. Tell me, it is discrete or continuous. Tell me this random variable x is discrete or continuous. Tell me, this random variable x is discrete or continuous. Tell me, this random variable x is discrete or continuous. Tell me. अरे बाबा इतना टाइम लग रहा है. It is discrete or continuous? Tell me. It is discrete. Because you see, you thought that it is 1 to infinity, so continuous. No. Even if it is 1 to infinity, these values are what? These values are discrete. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All these are what? All these are discrete. Understood? So don't think that it is till infinity, therefore it is continuous. No. The values which the random variable is taking here, they are all what? They are all discrete here. They are all discrete. Yes. And this is the probability mass function. Now, what is written? What is the probability that x is even? Probability x is even means what? X can be what? X can be 2, x can be 4, x can be 6, x can be 8, and so on, right? Now, so when I am telling probability x is even, that means what? I have to take p of 2 plus p of 4 plus p of 6 plus dot 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 dot. Continue, right? Now, what is the probability of 2? X being 2. In place of x, I will just put 2. So it becomes what? 1 by 2 square. Plus, what is the probability of x being 4? It is 1 by 2 to the power 4. What is the probability that x is equal to 6 to the power 6? And then continues. And then what? Continues. Right? You can see that it is a GP, na? It's an infinite GP, right? It's an infinite GP, right? It's an infinite GP where the first term is what? 1 by 4. And the common ratio is what? Common ratio is also 1 by 4, na? Yes. Common ratio is also 1 by 4. Yes, it is also 1 by 4. Yes or no? You see, what is this? 1 by 2 square into 1 by 2 square, na? So if this is the first term, how are getting the second term? By multiplying this one, right? So this is A and this is A into R. Yes, very simple geometric progression. Now for an infinite GP, what is the sum of an infinite GP? That is A by 1 minus R if R is less than 1, right? When the R is less than 1, this is what? The sum of infinite GP. So as per this, what will the answer to this? Tell me. The answer will be A. A is 1 by 4, no problem. A is 1 by 4, then what? 1 minus R. A is 1 by 4 and R is 1 by 4. So how much are you getting here? You will be getting 1 by 4 by 3 by 4, that is equal to 1 upon 3. Everybody understood this interesting question or not? Tell me. Everybody understood this interesting question or not? Yes, very interesting question, right? So, but it is not tough. It was just understanding of the basic. Same concept I used. I used the same concept, right? I used the same concept. Just here this GP concept was also used. This GP concept was also used. Yes? Now, similarly, can you give me this answer? X is greater than 5. Greater than equal to 5. Let us see. So try to solve this question and give me the answer. X is greater than equal to 5. I'll give you some time. I'll give you some time. Use this and find me the answer. Here also a GP will be formed. So try to form that GP and see what is the answer. 1 by 16. Okay, let us see that I have solved correctly or not. You see, this probability is what? You see, this probability is P of 5 plus P of 6 and so on, right? 5, 6, 7, 8, 9, 10, infinity. So you see, this is what? P of 5 will be what? 1 to the power this, then to the power 6. If you see this, okay, I am writing here, I am writing here. Here, this is also series, this is also a series, right? Infinite series. Here A is what? A is your 1 by to the power 5 is what? 16. Yes, 16. And then what is B? B is 1 by 2, na? B is 1 by 2, na? This is 1 by 2, na? Yes, it is 1 by 2. You know, not 16, it is 32 actually, sorry, 32, sorry, 32. To the power 32, yes? So, this is not B, R, sorry. So, when I use this formula, A by 1 minus R, so I can say 1 by 32 divided by what? 1 minus half, you are getting how much? 1 by 32 by 1 by half, that is what? 1 by 16. So, the answer is what here? The answer is 1 by 16. So, you can see that same concept which we are using before, they are using the same concept, but they are just varying the question, and therefore it's very important that we understand that different type of question. You see, like so many different type of questions are framed from only one concept. I have just explained one concept and so many questions are framed, and therefore it is very important that you study the courses in a very detailed manner as I am teaching here. Otherwise, what will happen, you will end up with 40 and then you will be seeing a video on what to do when you get 30 to 40 marks. Yes, and if you want to avoid that, you want to get into 70 marks, you have to study in this manner. Yes, nobody wants to score 30 marks and then you seeing a video and then again becoming depressed. Not required. Try to get 70 plus marks by studying in this manner. Yes, okay. Let us solve another question. Okay, here you see it is, now tell me this is which kind of function? Tell me this is discrete or continuous? Tell me which random variable is discrete or continuous? Random variable is discrete or continuous? So whenever I am asking that random variable is discrete or continuous, focus should go on random variable, not on the function. Don't go to the function. See, the random variable is discrete or continuous? Tell me. Because the random variable is discrete or continuous, and as per that, it is either probability mass function or distribution function. It is discrete. You see, the x is taking what? 2, 3, 4, 5, 6. These are all what? They are all discrete values. That means these functions defined are what? They are probability mass functions. Okay. So whenever you are getting confused that it is what density function or mass function, you should see that, you should see the random variable. Random variable is taking which values? The random variable is taking what? Discrete values, na? Understood? The random variable is taking discrete values. In the previous question you see, the random variable was taking what? Discrete values, right? The random variable was taking discrete values. Don't see this function. Function is later on. First you see the random variable x. X is taking discontinuous values or discrete values. You see here, this, you see, it is written what? 0 to infinity. That means what? It is continuous. The x can be 0 to infinity, anything. It's a continuous thing. So random variable is discrete or continuous. Understood? The random variable is discrete or continuous. So focus on that. In this question also you see, minus infinity to plus infinity. So random variable is continuous. Yes. Here you see, random variable was discrete. Yes. So to understand it is discrete or continuous, your focus should not be on the function. Your focus should be on the random variable x. Okay, random variable x. Let us go to the next thing. Okay, very good. So this is the question. Now, here we have to draw. We have to find out this table. Let us draw this table. X can take what? 2, 3, 4, 5, and 6. Yes. And then probability mass function. Let us draw it. Draw means plot the value, add the values. When the x is 2, it is written what? k into x minus 1. That means k into 2 minus 1. K into 2 minus 1 will give me what? Simply k, na? Yes. And then when x is 3, it is k into 3 minus 1. K into 3 minus 1 means what? 2k. Right? Similarly, for 4, what will be the probability mass function? Tell me. What will be P of x? Tell me. When the x is 4, tell me what is the answer? What is the answer for 4? Tell me. For 4, what is the answer? For 4, what is the answer? Yes, it will be 4k, na? 4k. X is equal to 4, I will use this one. So k into 8 minus 4. So 4k, right? And then when it is 5, so 8 minus 5, so 3k. Then 6, 8 minus 6 means what? 2k. So here I wrote the random variable and there. Now what is written here? X is greater than equal to 5. That means what? Either P of 5 plus P of 6. Now P of 5 is what? It is 3k. What is P of 6? It is 2k, right? That was 5k. But the problem is that I don't know k. I don't know k. What I will do? I'll use the property that summation of all probability mass function is always 1. Very easy. So if you add all of them, let us add all of them. 7k, 9k, 11k, 12k. So 12k is equal to 1 or k is equal to 1 by 12, and as Tejaswini has found out before also, the answer is what? 5 into 1 by 12, that is 5 by 12. You see, these questions are not tough, but again you have to be very thorough in your concepts, okay? You have to be thorough in your concepts and very structured. Yes, haphazard thing will not help, and some students thinking that, you know, before exam I'll attend a marathon and achieve full marks. Some students might do that, but all can't. So please stay away from such gimmicks. Yes, you should start mathematics and aptitude right away and make sure that you get your full marks in maths aptitude both in GATE and ESE. Yes, from now only you should start, you should not delay. Okay. Okay, now the next question. You see, earlier questions were what? The earlier questions were, we can see here, the earlier questions were the data was given in a disk, you know, not in words. But you can see that here the question is mentioned in words. Let us understand this question and solve this. What is written? The lifetime of bulbs manufactured in a factory is a random variable x years. So what is x here? X is the lifetime. The probability density function clearly determines what is in continuous. Obviously, the lifetime, tell me, lifetime of bulb, it will be a continuous function, na? Yes, lifetime can be, 1 day, 1.5 day, one and 3/4 day. Yes, 4 days, 4.5 days, or 4.27 days. It can be anything, right? So it is it's a continuous thing, right? Yes, it's a continuous random variable. Yes, so lifetime of a bulb will be what? It will be a continuous random variable, and therefore the probability is a probability density function. Yes, the density function is what? Fx is equal to k into x square. Very good. So density function is given. Now next thing is given what? The maximum and minimum lifetime of bulbs are given. That means what? This x is defined in the range what? 1 to 2. Yes, that means what? The function is defined in the range of 1 to 2. Yes, I explained something like this. They're asking you the value of k. Can you give me the value of k? Okay. I used one property, what? The integration of fx dx from minus infinity to plus infinity will be what? Equal to 1. If the range is from minus infinity to plus infinity. But if the function is defined between x1 and x2, here what? 1 and 2. Then this will be the property, right? If the function is defined in a particular interval, so if you integrate in that interval, that means what? Total probability will be what? 1. Very easy. Yes. So what I will do? I integrate this kx square. So when I integrate this k into x square dx, k into x square dx is equal to what? 1. So this will be what? K into x cube by 3. Yes. And then 2 and 1 is equal to 1. So from here what I will get? So first 8 by 3. and then 1 by 3, right? So 8 by 3 minus 1 by 3 into k is equal to 1. I'll get this as 7 by 3, k is equal to 1, or I get what? K is equal to how much? I get k is equal to your 3 by 7. So again you see, we are using the very basic definition of what? The very basic definition of your random variables and probability density function and probability mass functions. Yes. Now is this the end of everything? No, it's not the end of everything. Now this is your homework. Ladies and gentlemen, I am giving you one question as homework. Okay. I am giving you one question as homework. So what is the homework? The homework is the probability density function is given graphically. What is asked? Find the value of h. Now you can see that is a curve. That means what? Curve means what? It's a continuous function, right? Continuous function. That means what? And it also probability density function. Now what is the value of h? How to find the value of h? You see, the total integration of fx dx is equal to 1, and this is from this is within the limits of the function, right? With the limits of the function. This is nothing but what? This is area under curve, right? This is the total area under curve, right? Yes, when I'm writing, you know, f of dx is nothing but what? Sorry, nothing but what? Total area under curve. Yes, total area under curve should be equal to 1. So what is the total area under curve here? We can see, you see this area, you see area under the curve is this area, again you see this area, again you see this area, right? So this total area under curve should be equal to 1. So use this, use your whatever you want to do, and then find out the value of this h. Yes, so this is your, ladies and gentlemen, homework. Answer in comment section. This is your homework, and answer in comment section. Answer in what? Comment section. Okay, please do that. Now, is this the end? No, there are many other things related to random variables, right? And you know, distribution functions, right? There are concept of what? Finding the mean, the variance, right? There is concept of mean and variance, right? And standard deviation, yes? So all these concepts of, you know, mean, standard deviation, all these things, where you will find out how to study all these things. And there are different distribution functions also, right? See, we studied only the basics. There is, you know, a lot of things are remaining. Yes. So where to study that? Okay. So for that, what we're going to do is we have to. So some students who want to understand this concept in this manner, yes. If they want to understand this concept in this manner, yes. And therefore we have our BYJU'S exam prep app. Yes. So obviously everything cannot be covered here. Here we are trying to give you a sample of how to study for the GATE examination, ESE examination. Yes. And there, if you are more serious about your preparation, yes, you can download the BYJU'S exam prep app. You can go to learn with video lessons. Okay. And there you can find out engineering mathematics. Yes. Engineering mathematics, if you click it, you can see all the chapters are there, and each chapter is divided into small videos of 30 to 45 minutes, right? So all the chapters are divided into such subtopics. For example, like if you go to this topic of what? Probability and statistics, you will get, you see, small topics, you see. So we just studied the basic of distribution functions. Individually, there is binomial distribution. You will see the problems of binomial distribution. There is, you know, Poisson distribution. There is exponential distribution, the normal distribution. Yes, all the distribution. You see normal distribution, problems of normal distribution, uniform distribution, correlation and regression, joint distribution function. Yes. Now, obviously, everything cannot be covered on the YouTube channel. Yes, but certainly, whatever I taught today, this is the way things are being taught on the app. Yes, on the app you will find all these videos in a very detailed manner. Yes, so I will request you that you once download the app and you can see this lecture. 20 lectures are free of cost for all the students. Yes, and if you are interested, you can take the full course. Yes, and students who are interested in scholarships, many students told that sir they need help in scholarships. Yes, so we regularly conduct scholarship examination. Yes, so on 30th of April, okay, at 12 p.m. there is scholarship test happening. So those students who want to avail scholarships, yes, they can avail this by registering for this particular scholarship test. So please register for the scholarship test. Yes, and if you have any issues, you can always message me on my number. This is my number. I might not reply instantly, I might be busy, but I will reply taking my suitable time. Yes, this is my number. So anyone student wants to have any discussion on this, on the different how to approach subjects and other things, and whatever doubts they have, they can always refer to this number. Okay, so this I explained, all the things are given, and students want more details and more things they have doubt. Okay, in the BYJU'S exam prep app and also in the website, you will get this talk to counselor option. If you click this, you will be assigned a counselor who will clarify your other doubts also. Yes, about the course details and what features are there, like we have tablet recorded lectures and how to practice question test series. So there are many aspects to the preparation, and all those aspects will be discussed thoroughly by the counselor for you. That option is given in the talk to counselor thing also. Yes, so thank you very much. This was the end of the class. Yes, I request that we will be taking this aptitude boot camp. I want to take important topic of what? Important topic of your exponents and logarithmic. Yes, it's an important topic. Okay, exponents and logarithmics. I will take this topic on your Thursday 6 p.m. Okay, Thursday 6 p.m. So I'll request everyone, this is an important topic, and aptitude becomes very important for all the examinations, especially ESE, GATE and other exams which are giving, right? So thank you very much. See you on Thursday. Okay, see you on Thursday. Thank you very much. Bye.